In this video, we're going to discuss parameter versus statistic. So, what's the difference? Parameter describes a population. So that's the entirety of uh, objects that we want to learn about. For example, if we want to find out the average income of an adult in the US, our population is all adults in the US, and the parameter would be the mean of everyone in that population. So the only way to figure out a parameter is to do a survey of the population. Now, the statistic, on the other hand, is an estimate. So how do we come up with that estimate? We select a group from the entire population. We take measures that so that that group was representative of the population, but it is a smaller group. It's a subset from a population. And then we calculate the average salary in that subset or subgroup, and we call it a statistic. So statistic describes a characteristic of a sample or a subgroup of the population. So when we talk about parameters, parameter describes the population. When we talk about statistics, statistic describes a sample. And the distinction between the two is very, very important. It is so important that we use different notation for both. For example, to describe the size of the population, we use a capital N. And to describe the size of a sample, we use a lower case n. So a parameter can be obtained only by census, and statistic can be obtained by sampling. Parameter remains constant, although most of the times is unknown. That's what a lot of times we're trying to estimate using samples. Now, to understand that the average salary of the entire population of adults in the U.S. Is not variable at a certain moment of time. Of course, some people are losing jobs, some people are finding jobs with time. But if we just say this 1 second, the average salary is constant. With statistic, it will vary from sample to sample. So if we have the same population and we take, let's say, 100 people and calculate their average, and then we get a second 100 people and calculate their average, the averages will slightly differ. So that's what it means. It varies from sample to sample. Now, the most common use of statistics is to estimate the value of the corresponding parameter, which is usually unknown, as I mentioned before. The statistic we use to estimate the parameter is called an estimator or an estimate. Some estimates are better than others. And while random guess may satisfy the definition of an estimate, we understand that a statistic is better than just guessing. Another definition of an unbiased estimate. An estimator is called an unbiased estimate of the parameter if the mean of its values in the long run equals the parameter. Otherwise, it is said to be biased estimator. In other words, if we get many samples, calculate the averages, and then take the average of the averages, it should roughly equal the average of the population, the average salary of the entire population. So that's an unbiased estimator. Okay, so here's again, the table that brings this into focus, the average, the unbiased estimator, the average of its values in the long run equals the parameter. Biased, the average of its values in the long run does not equal the parameter. So example for biased, guessing student heights. So the person could, for example, guess like lower than the true value of the heights, or always guess higher than the true values of the heights. So on average, he or she will not guess the true population value ever. But if we estimate using samples, eventually we'll get the feel of the true value of the population. As we mentioned before, it is very important to distinguish between parameters and statistics. So much so that we use different letters to represent parameters versus statistics. So to represent parameters, we usually use Greek letters. So for example, the average value or the mean of the population is denoted by Greek letter mu. And the same value for sample is denoted by X with a bar. Even though if you notice the formulas are the same, add all X values, divide by the population size, and add all X values, divide by the sample size. All right. So yeah, the formulas are the same, the notation is different. So you should be able to tell by looking at the notation whether we're talking about parameter or statistic, because as I mentioned already, and I'm going to repeat it again, we're going to use statistic to target parameters. Okay, the same 5 team members of the soccer team could represent a sample and could represent a parameter depending on the context. So let's take a look. When we're interested to learn the average height of the 5 starting players, that would represent a parameter because this is the group that we want to learn about, that in its entirety, right? We did not select us. It's not a subgroup from another bigger group. No, this is the group that we want to learn about. Now, let's read this description. It says, when we're interested to learn the average height of the team, but only observed the height of the starting 5 players, that's an example of a statistic, because 5 players is not the entire group that we want to learn about. The entire group is the average height of the team, which is more than just 5 players. But these 5 players represent that bigger group. So therefore, it is a sample. So in this video, we talked about parameters versus statistic, and we're gonna continue to the next video. And in the next video, we're gonna talk about measures of dispersion or measures of variation.